So we're going to do one more example of using our formula to answer questions about exponential growth and decay. So make sure you remember formula is PERT, P-E to the RT. And the question that may have been bubbling around in your mind, and I remember when I was in algebra and I was learning to do exponential growth and decay, it bubbled around in my mind. The question was, how do they actually figure out what half-life is? We were talking about carbon-14 having a half-life of 5,730 years, and we've only known about radioactivity for about 100 years. How could we possibly know the half-life of something that takes that long to decay away? So we're going to do an example of trying to figure out a half-life in sort of a scientific fashion. Let's imagine that this is 100 years ago and we're just discovering radioactivity for the first time ever, and we've got a sample of some radioactive material, and we're going to keep the numbers kind of easy. We're going to say we're going to start with 1 pound. And then we wait a reasonable human length of time, 200 days, not a particularly long time, it's less than a year. And when we go back, we realize, hey, some of the thing is gone. It's no longer a pound. It's less than a pound. It's 0.998 pounds only. And we're going to use this information to eventually figure out what is the half-life of this material. The steps for doing this are luckily the same as the steps we've been doing for all exponential growth and exponential decay problems. The first step is to figure out R. Now, remember, R is the decay rate. That's not the same as the half-life. So once we figure out what the decay rate is, we're going to have a second step where we have to figure out what the half-life actually is. So, how do we find R? The same way we've ever done before. Take our formula, plug in all the numbers we know. We've got A equals P-E to the RT. Well, P was 1 pound. T was 200 days. Oops, sorry. There we go. 200 days for T. And A, remember A is the final amount, that's the 0.998. So if we plug in all the information we were given about this radioactive substance, whatever it is, we would be plugging in and producing this equation here. And then we solve this for R. One of the first things, of course, we're going to do is ignore that 1, because 1 times anything is just that thing. But then we're going to move E to the other side, and then divide by 200. So figuring out the decay rate is pretty straightforward. And let's figure out a decimal form just out of curiosity. But as we've noticed in several problems we've done so far, the decimal is not really very useful at this point. It's negative 0.000001001, 00134, etc., blah, 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 blah. So yes, it's a very slow decay rate. In 200 days, only a little tiny bit of it decayed away. So it's a very low decay rate. But that wasn't the question. The decay rate wasn't the question. The question was, find the half-life. So, step 2, just like it's always been, use R in the formula A equals P-E to the RT to answer the question. And the question here is, what is the half-life? But it's a little better to sort of translate that into more normal language. When we say half-life, that's kind of a fancy term. What that actually is meaning is, what is the length of time it's going to take to get to half of the starting amount? In this case, we know what the starting amount was. It was 1 pound. So half of the starting amount would be half of a pound. So if I plug everything I know into the formula, I've got this. Final amount is 0.5, starting amount is 1. R, we could use the decimal, but I don't want to. I'm going to use the non-decimal version of it. R is natural log of 0.998 over 100. And we want to know how long that takes. What is the length of time to get to half of the starting amount? And this is not a particularly difficult equation to solve either. Again, I'm just going to ignore the 1 because 1 times anything is that thing. I'm going to move the e to the other side, turn it into a logarithm. And then, like we did last time, when you've got a fraction here, you could divide by it, but then you get something that's really tricky to type into your calculator properly. It's a little better to multiply the denominator up first and then divide by the natural log of 0.998. You get a much cleaner, easier thing to type into your calculator. So let's see what we get there. 200 times natural log of 0.5 divided by natural log of 0.998 is 69245.38021, etc. So whatever the substance is, it could be a brand new discovery nobody had ever heard about before. By waiting 200 days, only 200 days, we can tell that it's going to take almost 70,000 days to decay to half. So the half-life, we could report to our friends, we've discovered this stuff, the half-life is almost 70,000 days, even though we only waited 200 days. So you don't have to wait the whole half-life to watch all the decay actually happen all the way through to the halfway point to know what that halfway point is going to be. You just use PERT in the same fashion that we've used it before. Find R, and then use R to answer the question.